Welcome to Laurier's Teaching Excellence Conversation Series. I'm Mary Wilson, Vice Provost Teaching and Learning at Wilfrid Laurier University. And throughout this series, I'll be joined by recipients of the Donald F. Morgenson Awards for Teaching Excellence to celebrate their exceptional teaching practices, learn about their teaching philosophies, and discuss the future of higher education teaching and learning. Today, I'm delighted to be with Allison McDonald from Laurier's Biology Department in the Faculty of Science. Allison received the 2021 Hoffman-Little Award. Allison's dedication to promoting scientific literacy and advocating for equity and inclusion in the scientific community are deeply embedded throughout her work, and her use of universal design for learning and innovative, flexible assessment strategies that make her classroom more inclusive and engaging. Her multifaceted contributions to her discipline, the Laurier community, and to the lives of her students make Allison an exceptional recipient of the Hoffman-Little Award. Welcome, Allison.
Thanks, Mary. It's wonderful to be here and talk to you today.
So, Allison, one of the things that really stood out in your awards package was your work to make the scientific community more inclusive. And certainly the science community has become increasingly diverse over the previous decades, but we still have a long way to go. So I'm wondering if you can talk a little bit more about the impact that inclusion has on the discipline and your aspirations for your students. And maybe you could also comment a little bit on some of the changes that you've seen in your classroom and in your discipline.
Yeah, so we've known for a while in science and in a lot of fields that we're having some difficulty initially recruiting fairly diverse people to science. So we've known that's been an issue for a while. And that's sort of where the focus has been for quite some time is getting people into science. And what we're seeing now is more of a shift towards, we're not so much having a problem recruiting people. The problem now seems to be in the retention piece. So people are very interested in science. They want to be scientists. They want to learn about science. They come to school and they have some types of experiences that at some point turns them off science or makes it feel as if it's not a very welcoming space for them. So that's sort of one of the things that I'm trying to get at in some of my teaching is making sure that anyone who's in my classroom or in my lab knows that there is a place for everyone in science. And historically, science has really excluded a large number of people from doing science, and that is certainly a problem. So in a lot of my classes, the first thing that I'll think about is, well, what biological content do we need to know? But then one of the other questions that I ask is, what opportunities exist within my classroom space and the curricula that I'm going to share with my students to actively call out some of the problems that we've had in science in terms of representation, call out what I see as future problems that we're still continuing to have, and then start talking about some solutions or some changes or some dismantling of some of these institutions or ways of doing science to make things better in the future. And that's sort of where the equity piece comes in.
It's really important work for us to do to expose the students to the role models that exist in science disciplines as well. And I know there's been some really exciting initiatives of late, even on social media, where there were like naturalists, women, people of color who are pursuing science as their discipline and their passion. Is that part of what you endeavor to do within your classroom as well, is to play that role of being a mentor and an advocate for their continued pursuit of science? Because certainly you're a very accomplished woman in the sciences.
Yeah, and that's, fake it till you make it is sometimes what I like to tell my students. But then the other thing that's helpful is if you can see it, then you can be it. And so we do need those role models. We do need to see women doing science. We do need to see members of the LGBTQ plus 2S community doing science. We need to see Black people doing science. We need to see Indigenous people doing science. We need to know that there are different ways of knowing rather than the colonial, westernized methods that we are familiar with in science. And science is sort of one of those tricky things because we do teach science in a particular way. It's been done that way for quite a long period of time. And to actually admit that perhaps that's not the only way of doing things or the correct way of doing things can be really difficult and challenging for a lot of people to accept. and to embrace that perhaps something different and something better could be the way to go in the future. So within the curriculum, when we're talking about particular discoveries, I like to call out, okay, here is a non-typical stereotype scientist person who isn't, a middle-aged white dude who's contributed to the field in this way. And the other thing that I will do is we have sort of famous scientists from the past, and while their scientific discoveries might have been fantastic and amazing, they weren't very nice people. And so teaching students that science is done by people have failings, people have biases, people have yucky opinions that are not okay, and calling some of that out as well, so that they know science doesn't occur within a vacuum. It's part of culture, it's part of society. We can certainly do better. And how do we do that moving forward?
Yeah, that process of calling it out within your classes must be revelatory for some of the students, and I think really empowering as well to hear a professor recognize that within the classroom. It sounds as though there's a lot of positive things that are within your scope of influence as an educator in the classroom. Can you talk a little bit about your observations of lab culture and what we might be able to do within research lab environments, particularly for students who are further along in their academic careers?
There's a lot of work that we can be doing there. It's one thing to do these things in the classroom, or we do some practices and we do assessments, but these laboratory spaces are equally as important. And that's where we're losing a lot of people. They're coming into spaces that are hostile, quite frankly, or they feel they don't belong there, or they're very misunderstood. So again, that's where a lot of the mentorship comes through. For me personally, it's recognizing, I had some particular experiences as a woman in science that I did not appreciate, becoming aware that those barriers are there for me, but there's barriers for lots of other people, or people who are perceived as other within the sciences and don't feel part of the community. So a lot of this, the baby steps, or the first steps, or the easy steps, are changing policies. This is what acceptable behavior is. This is what it isn't, making that really clear to people. But that's only the first step, because the second step is walking the talk, is actually in your day-to-day interactions with people, standing by what is on paper and what it is that you've said, because it's not so much what you say, it's what you do. And there are, some people are kind of resistant. We have this concept in science of academic rigor, like we have in lots of other fields. And unfortunately, my view of rigor is kind of tainted. I sort of see it more as gatekeeping and excluding people rather than bringing them along and including them. So I think there's a fair bit of mindset shifts that have to happen within the sciences as to what do we consider to be excellence. And I think that needs to change, and those metrics need to change. We like to quantify and qualify things in sciences all the time. Yes, you can do that when it comes to doing research, but maybe that's not the best way to be evaluating accomplishments or contributions to fields of science. And there is a lot of literature out there that shows very clearly that by having diverse research teams, you're much better positioned for discovery and innovation, and probably a more pleasant learning environment for everybody, quite frankly.
I really like that notion of troubling that historical orientation toward rigor and making sure that we're clear about the value of the historic approaches that have been used, and also the blind spots that potentially lay there, and how bringing in multiple perspectives and experiences, modes of questioning, modes of evidence gathering, validation of knowledge can really start to build that innovation or creativity, or maybe help us solve problems in ways that we would not otherwise be able to do. And this whole notion as well of that balance between attention to policy and culture and intention around changing policy and culture seems like a really effective mix, and something that we could build across multiple contexts, not just within biology, but in other disciplines and other lab environments as well. So I really appreciate your perspective on that and the work that you've done, the successes that you've had. I think that would be a great benefit to others who are feeling that sense of dissonance, right? That trouble that you sense that something's not quite right in the culture of the classroom or the culture of the lab, and that you want to create a more inclusive and welcoming environment for learners, because I think it empowers people in a different way. It invites contributions in a way that people feel safe to express those fundamental questions, to sort of draw together those insights into what else might be possible for methodology or problem solving. So it's a really significant contribution, Allison. I'm really glad to know that the work's going on at Laurier. I know that in part of your package as well, there was a great deal of observation of all that you're doing to help to develop scientific literacy as well. Can you help us to understand what you mean by scientific literacy? And then a little bit about how you intentionally promote the development of that in your students and also beyond Laurier.
So I think scientific literacy, there's a couple sort of components. As I said, when you're learning anything, there's sort of the base content. There's understanding concepts. There's understanding the language that we're going to use when we're talking about things. Scientific literacy to me would be great if every person in Canada and internationally understood it. And I think it's just a basic understanding of science, or the way science is communicated and described, that it's effective, that if you explained it fairly well, pretty much everyone would understand what it was that you're talking about. The problem in science and a lot of other fields is we have this really heavy duty jargon, these language specific terms that we use in science all the time. And you sort of forget after you've been in science for a bit what it was like when you first started out and you didn't know what some of that language meant. Well, many Canadians don't know what that language means either. And so, you know, it's not a case of dumbing things down. It's a case of making things easy to understand. You don't put barriers in place by using language that not everyone is going to understand. So that's sort of the first part of it. The second is definitely that communication piece, the believing that everyone has the right to understand science, whatever topic you might be talking about. And we sometimes have this problem as scientists, even when we go to conferences in our own field, where people will give a presentation and they'll just forget that not everybody is into their particular topic, or maybe the last time that they heard about this was in a first-year biology class and they're just finishing up their PhD. So a lot of it has to do with language, a lot of it has to do with communication, and those are things that I don't think are specific necessarily to science. They're probably specific to any academic concept or context. We're sort of had a light shone on this problem in science, I think, particularly in the past 18 months, given what's been going on worldwide, where we really have an understanding that, oh, there's a lot of Canadians who are getting misinformation, getting disinformation, or just, you know, can't evaluate the source of information to an extent where they should know, okay, is this a valid place for me to get information that's really important? Or is this a really junky place to go for my information and it's not going to be accurate at all? So scientific literacy, I would argue, is important for everybody, particularly for our science students, because what I would like them to do, whatever they do after they leave Laurier, is be able to be an ambassador for science, to be able to go out into their community or communities and talk in a meaningful, clear, concise, and factual way about scientific knowledge and its impacts, and, you know, share that information with people who are open, or perhaps aren't open to hearing some of those ideas as well.
It's a great observation. Like one of the things that really distinguishes the disciplines like biology from other fields is that specialized language and way of thinking about the problems that you're solving and the approaches that are being used. And that helps to make it special, but it can also help to make it inaccessible. And being deliberate about taking the time to explain the fundamentals and situate the insights that are being gained through research and development within the field so that a broader audience can appreciate it is, I think, an important strategy to take for precisely the purpose you're talking about, which is, you know, for folks like me who are humanities graduates or a professional program graduate, to have that vernacular, that understanding at a fundamental level ourselves, so that we're in when we're in situations where there are significant human problems like the pandemic or climate change, we are able to interpret and act responsibly and with a capacity to understand that is a little bit more broad spread than just those who study and work within the field. So I think that that is a laudable thing to do. And the fact that you set your graduates up to be able to do that subsequently as part of their practice is a really exciting thing as well. So you've talked a little bit about inclusive teaching practices and also building scientific literature. Can you talk a little bit about what or who has inspired your teaching practice and what's exciting you today about your teaching practice?
A lot of my teaching practice sort of at the beginning was what had previous professors of mine done. And that was sort of two-pronged. Was one, what did they do that I liked, that I found really helpful? And two, what did they do that I hated? And the idea initially when I first started at Laurier was to do lots of the first one, things that I thought were great, things that I thought were effective, and then to avoid at all costs the second one because I felt they were really harmful. And so I think that was an okay place to start. And then as I gained more experience and thought a little bit more deeply about my teaching practice and what I saw other people and other colleagues doing, it really came home for me that there was a lot more that we could be doing in this area to make sure that science education was a lot more accessible for everyone. And probably around 2015, 2016 is really when I had first read about the concept of universal design. And so universal design is used in a lot of fields. It's used in architecture, it's used in business, it's used everywhere. And then it sort of got embraced pretty vigorously within the educational context as well. And it's the idea that when you're designing a learning space from the ground up or at the very beginning, you build into your course or your laboratory experience or whatever it is that you're going to run, tenets of this idea of universal design. And so universal design basically means if I have done a good job, anyone who's coming into that space can be successful. And there's certain things that you can do, and certainly each year I build on previous successes, and then if I've had a couple failures, I'll try something new. So it's a lot of experimentation as well. But I think that's sort of a vital mind shift. In sciences, I do have some colleagues, and we talk about these things quite frankly, where people sometimes will use certain courses to weed out students that they feel are weaker or that shouldn't be there. And that again comes back to that sum of exclusion ideas that I'm just not okay with. And my viewpoint is the opposite, is if I've done a good job designing the class and I've done a good job building in supports for everyone, then there's no reason that all of my students couldn't get an A in my course. And that, I think, is a pretty uncomfortable place to sometimes hang out. But it's what I feel morally is the thing to be doing, and what I feel, allows me to sleep well at night. And so there are lots of things that you can do in terms of universal design, and it can be, physical spaces. Can we make sure that everybody can get in and access and move around freely if they choose to do so? It has to do with the modes of delivery. So our typical lectures often aren't super accessible. It's somebody up there talking. Maybe they have a microphone, maybe they don't. So if you're not using a microphone, you're losing some of the students in the course because they can't hear you. It's, during this pandemic in particular, a lot of my online classes, I made PowerPoints available. I do a PowerPoint with a voiceover. I do a recording of that. And then I also provided a text transcript of everything that I had said or spoken. And so what's been awesome was originally I made these changes basically to make it accessible. And the people I was thinking about it originally were groups in particular who'd been historically excluded, but it turned out to be awesome for everybody. So I had many students in all of these classes. I had done the transcripts for some students who were perhaps neuroatypical, or some students who had oral processing disorders or some kind of learning challenge. But anyone in my classroom often found those transcripts really useful. And so that's, I think, the amazing thing about universal design is, yes, it takes some time up front. It takes a little bit of work up front that maybe you're not used to doing, but it's great for everyone. And then the other thing that I found is the payoff is quite huge. So one, you also feel good about yourself. And then two, it massively cuts down on administrative stuff that I have to do later to try and accommodate people, because technically they've already been accommodated. And that's sort of what I'm aiming for as the goal is people who come into that learning space won't need accommodations because they can just be successful as how the situation has been set up. And that's sort of what I'm striving for. And I'm certainly getting closer and closer every year. Every year there are things that I find that, oh, I got to retool that because that's not quite working how I would like. But I certainly feel a lot better about my teaching practice. And I feel that the space that I'm making for the teaching and learning is a lot safer for a larger number of students and learners.
Yeah, I think that is the perspective that often has educators move toward more inclusion of universal design for learning principles in their teaching practices, because the time that you spend in advance putting in those proactive strategies for students to be able to access the learning through multiple modalities and repeatedly so that they can learn more deeply, more richly, makes a big difference in terms of their ability to succeed in the course. So can you talk a little bit about how what you've learned about universal design has influenced your choices for assessment strategies in your courses?
Yeah, there's sort of the low-hanging fruit for me. So, you know, within a classroom space, sometimes physically you're going to have constraints, and that may be beyond your control, right? You get assigned a room. The room is what it is. You may be able to move the chairs around. You may not be able to. The screen is a certain size. Do you have access to a computer, et cetera, et cetera? So yes, I'm not saying there aren't constraints. There certainly are. But when it comes to assessment, you have a lot of freedom there. You have a lot of space that you can utilize. And so one of the big choices that I made when I started at Laurier, which had been based on my experience as an undergraduate student, was I have never in any of the courses that I've run had a final examination. I hated them as a student. I hate them as a faculty member. I personally don't like them very much. I find that they're exceptionally stressful for the students, and then they're also not a lot of fun for me. So that was sort of the origin of this mindset, was there's got to be a different and hopefully a better way to do things. And then the other thing that I try and do is be a little creative in the assessments that I design. So what is something that I, as an undergrad, might have thought was cool or interesting or actually fun to be doing as a way of you know, showing and demonstrating my knowledge. So there are a couple of interesting things that I've sort of done. So in one of my courses, I do what's called a microbe trading card. So this is kind of an infographic on the front with some text on the back, and it's very similar to a Pokemon card. So the student picks a microbe, they do some reading of the primary literature, they write a little descriptive blurb on the back, they do a drawing of their organism or a graphical illustration of the organism on the front. And that again gets to that scientific communication piece, because anybody should be able to see the card and understand it and think, hey, that's a really cool organism, tell me more. So that's one example of a different kind of assessment. I do a fair number of case studies as well, where here's this weird thing, here's a problem, let's work as a team to come up with some creative solutions in a way to, again, communicate that to a broader audience. And then I have sort of smaller assessments that are a little more frequent, but there's a lot of flexibility. And that flexibility piece is so important because it makes it so much easier for the students and so much easier for you, right? If it's, we're going to do mini essays, they're going to be personal reflections, we're going to do 8 of them over the course of the term, and you only have to do 5. And if you want to do all 8, great, then I'll take the best 5. And if you just want to do 5 because life is busy and you got too much going on, then just do the 5 and we're all happy, right? But that flexibility piece is really key, you know, at any time, because people are busy, life happens, you know, you have a death in the family, you have a sudden disability because you busted a leg, you got food poisoning and you're throwing up, right? By not having exams and trying to cut down on the number of tests and making these assessments a little more evenly spaced and much lower stakes, I think it's just a much nicer experience for everyone, for the students in terms of what they're being asked to do to demonstrate their knowledge, and then for you in terms of sort of spreading out the marking load to something that is a lot more manageable over the course of the term. And then they see you as a person who's trying to help and guide them through this course and through the material, instead of somebody who's a really heavy duty authority figure and very rigid and very inflexible. So again, this again contributes to that safe space where everybody feels that they can be successful. They have the tools to do that. And then what they're being asked to do in terms of demonstrating their knowledge is very reasonable, but also quite flexible as well.
Yeah, and from what you're saying, the connections between what you're hoping students will be able to learn, both about science as well as science communication and themselves as learners, is really thought through in the nature of the assessments that you're providing and the strategies that you're using to give them multiple opportunities to demonstrate their achievement of the intended learning outcomes in the course in ways that are respectful of, as you say, the complexity of life these days. It really would focus the course on the learning for the students in really tangible ways. So I can imagine that it creates a more engaging and joyful teaching and learning environment in your courses too.
Yeah, it certainly does. And that gets reflected in the comments that I get back on the evaluations, or just things that students will say to me after class, or emails that they will send. And sometimes they're surprising. You know, it's a little change that I made that I didn't think was really going to be a big deal, but it made a huge difference in somebody's life that term because they were dealing with something else, you know, something else that wasn't flexible. And thankfully at that time in my course, there was some flexibility there. And so it worked out well for them.
That's brilliant. So it's clearly your students inspire your teaching practice through the feedback that you receive. Have there been other exemplars, other colleagues who you connect with regularly, whose teaching practice really is extraordinary, and you learn from them in conversation or through reading their scholarly teaching work?
I have lots of conversations with colleagues, lots of good friends and colleagues in biology who do weird and wacky and wild stuff. So a great example is my friend Tristan Long. So he does a first year, one of our first year bio classes. We always kind of laugh at him because he has this cool cart that he drives around the science building as he goes to lectures when they're in person. And it's just a lot of activities and a lot of engagement in his classroom. So that's, again, something that I try and emulate. You know, when I talk to people at conferences or other spaces, I will often ask them, you know, what's working in your teaching practice? What is not working? What should be avoided with a 10-foot pole because it's really not a good idea? But again, some of those experiences, you know, a lot of what's informed me is things that I was either exposed to in the past that, again, I thought were great or I didn't like, or just, you know, some generalized reading where somebody sort of mentions, oh, a particular assessment, and here's what I tried, and this is, you know, this is what was valuable, and this is what kind of the drawback was. I feel pretty confident, and often have from the very beginning, to change things up, to challenge, okay, it doesn't have to be this way. There's nothing saying that I can't do this kind of assessment or give this a try. One of the things I'm thinking about sort of in the future is there's been a lot of talk in higher education about ungrading, decoupling a number from the evaluations that you do. And I have to do a lot more learning about that to see if, you know, is that a feasible thing? And many colleagues have started doing that, but what they have told me is start with one assignment. Don't do your entire course.
Yeah.
Pick one assessment. And, you know, that's sort of what I do, is sort of baby steps, is I'll pick one thing in a course that I'm maybe going to change up that year, make some modifications. And that comes down to, again, just the type of work that I do. I'm a scientist. I like to tinker, I like to experiment, I like to try new things. Sometimes it works out beautifully, and sometimes it's a very tragic dumpster fire. And you don't really know that until you run the experiment, but you're always going to learn something valuable from that. So colleagues have been great when I've asked, you know, really vague questions, really particular, specific questions about what they feel is working and not working in their spaces. And everyone's been really generous sharing that information. And then I try and pay it forward. So we have a lot of new faculty starting in our department. I try not to be too pushy, but I will sometimes sort of say, you know, here's what's worked for me. Here are some things that you might want to consider. If I know there's something that's, you know, don't do that thing, then I will try and give them that warning before they're designing their courses, so that, you know, they don't have to reinvent the wheel, make the same mistakes that I've made. And the students are spared having to have that experience.
So that combination of cultivating your sort of personal learning network, talking to colleagues and friends who are inspiring, reflecting on your own teaching practice, taking the time to think about what's working, what's not working, what do I want to try and why, and then also learning from your students' learning and their input, all really powerful ways to think about your teaching practice. And the other thing that you're doing, Allison, that I think we often take for granted is just inviting conversation about teaching. In your department with your colleagues and normalizing that as part of the ways that we engage in our professional work. We don't always have those really great, rich conversations about teaching in ways that say, I'm trying this or I want to do that, and it's not quite working the way that I had hoped or anticipated, or I've read this, what do you think? Those aren't necessarily common conversations that we invite and get to participate in, but they are awfully enriching when it comes to thinking about what we can do within our classrooms and keeping our teaching practice engaging and rewarding as well. I think it's part of it is having those conversations and taking the time to read and learn as well. So when you think about the future of teaching in science disciplines, reflecting a little bit on the last year and a bit, but also the span of your career, what do you hope for the future of teaching in your discipline?
I think one of the dreams that I have is again, just this idea of universal design and just getting more people, frankly, on board with that. Of realizing, yes, there are times when you up at the front of a classroom giving a lecture might be the most effective approach, but to recognize that there are probably times where a different kind of experience would be a lot more effective, would be a lot more engaging. And I know this from running activities in my classroom. The stuff that they remember are the things often that they are doing, the things that they are interacting with peers to do. They feel a sense of accomplishment, and it really can be that simple. The other thing that I think is exceptionally important, especially in today's climate, is actively indigenizing your curriculum. And this is something, again, starting baby steps, starting very, very small, having a couple of small successes, building on those to get to a point of comfort, right? And one of those things to accept when you're changing your teaching practice up or moving into new spaces, you have to be comfortable with being uncomfortable. And it's okay to be uncomfortable. And sometimes that is actually the point. And it's hard to hang out in uncomfortable spaces, but it's necessary. And I would think that in many of our disciplines, we have a duty to actively do that, to move into spaces where we feel uncomfortable, because this is how a lot of people in science have felt for millennia. So I can be okay being uncomfortable for a couple of minutes because I have colleagues and students who've been uncomfortable the entire time they've been in my discipline. To just sort of recognize that. And that's sort of the first step. Eventually I would like to get to a point where we do a decolonization. That's going to be a lot harder work, a lot more complicated work. But I think, the starting part of these steps is to start having these conversations. These are things that, a decade ago when I was starting out, weren't really on many people's radars. We weren't having conversations about these things. We need to have those conversations. They shouldn't just be random conversations in hallways, right? We should be starting to dedicate some of our training, some of our orientation, and many of our professional associations at conferences talking about these concepts, because this is the only way we're going to make science and other culture and places comfortable finally and accepting of other people who have wanted to join us in science for many, many years, but have been excluded actively from doing so.
Brilliant insights, Allison. And yeah, absolutely. There's a lot of change that still needs to happen. And learning is fundamentally change. It's a change in our appreciation, understanding our skill sets, and that can sometimes be a very uncomfortable place to sit, as you say, but that's also where the growth comes and where the excitement and re-engagement in our disciplines and our teaching practice is often the richest. And to have you inviting more of that deliberately, I think is wonderful for colleagues who are joining the Laurier community as new educators, and also for the students that we have the privilege to teach. So I really want to thank you for joining me in conversation today. And I want to thank the audience as well for joining us to celebrate teaching excellence and student success. I hope you'll join me again in the next conversation as I continue to celebrate our award recipients and highlight exceptional teaching at Laurier. Thank you.